Okay, it seems like everybody comes back a little early instead of 15 minutes. So let's continue today's discussion. We just talked about problem number 2. Now we're going to talk about problem number 3 of 2022 January contest or USACO contest at Platinum level. Frankly, this is a math problem more than anything else. What this problem is let's say you have coordinate, okay? So you have one group which is made by a bunch of vectors, let's say made by those 3 vectors. And then you have another group which, let's say, is made by 1 vector for easy explanation. The question is, what is if you pick 1 from this group and 1 from this group, what is the furthest distance if you add those vectors together? For example, for this one and this one, right? So the vector you add together, it will be, this is going to be a final one, right? Or you can do this and that. So that vector is going to be this, okay? Or you can do this and that. That vector is going to be this. So obviously this one is furthest. Okay. The question is, what is the furthest one? So let's say by this plot, actually you already get some hint. Let's say if I have a, let's redraw this. Okay. Let's in previous case. Okay. So let's say, that is my, group B. Let's say this is my group B. This is my group A. Let's say in group A, I have another vector, which is, like this. Okay. You will not use this, and this will not form the vector, a vector that is further away. And instead this and that will form it. So if you remember the convex hull issue, okay, let me draw this like here, okay. If you remember the convex hull issue problem, you actually, if you think about this group A, you only need to use the vector that forms a convex core. Anything inside will not form, will not make it bigger, right? And you can see it like from here, obviously. So that's the first observation. So what we can do is, then we can have a greedy algorithm. For each, we can form the first one, right? First convex, for the first group, we form the convex hull. Then for second, then I add the second group, right? For the second group, I can just add it in, right? So I add, I take those vectors, right? Let's say the second group have, B1 and B2. For each one, then, this have A1, A2, A3. A4 I don't need because it's not inside the convex hull. Then for each of this, I form, for each of this and each of this, I form another set, right? Added set. Then I take that convex hull, then I add another one, then I add another one. Okay. That will take n squared. Convex hull also take log n, right? So my n here, I should say t squared, total number of these things. Let's just call it n. instead of T. So it doesn't work. It has to be unlog n instead of n. I have to move this from n squared log n to n log n. Okay, how can I do that? Basically, each time when I form, I cannot do all the combinations. Basically, I have to get a way of doing all the combinations. There is actually a math. This is actually a math problem. If you don't know this, I don't think you can figure it out easily. So what this problem is called Minkowski addition. What does it say is if you have two convex holes, right? So the problem we had a moment earlier is we try to figure out how can we add two convex holes together, right? So, you know, A form a convex hole, B form convex hole, how to make the combination of A plus B and then form convex hole. What I did is for every A plus every B, make the combination that made n squared. I want to take that n squared to n, okay? So there is people actually already studied this and they figured out, right? Here is a two convex hole plane. What does this do is basically to make the explanation easy, when I form a convex hole A, right? So let's say I form a convex hole A. It is formed by, you know, this vector, this vector, this vector, this vector, this vector, go around the circle. Okay. Let's say I formed the convex hole B. It was by this vector, this vector, this vector, those three offsets. What you need to do is you take all of those vectors, not the original this, the edge, the periphery. Then you sort it by the angle, right? The polar angle. And the new one, the new, you know, let's say this convex hole plus, let me just call it plus, is basically you sort all of those by this polar angle. And it starts, you do, for example, you take this one is the first one, and let's imagine this one is the second one, you take the second one. Let's imagine that's the third one, you take the third one, and then you form that convex hole. Okay, so that, you know, you don't have to do all the combinations, then that becomes unmarked. Okay, if you don't know how to the math, I don't know how you can figure it out. Maybe you went here during the competition, you can Google how to add the two convex polygon together. In ROI, you cannot Google it. On USACO, maybe you could if you really want to do that. So yeah, that's approach. Just to illustrate this, I wrote a very simple Python code because I want to draw it. So I just use Matplotlib. So so I basically you know, make one convex hole, make another convex hole. Then I took the third step, you know, which is that's all the combinations. You know, I plot all the combinations. If I add all those vectors together, this is a third convex hole. If you just take a look, this, you know, for the new A plus B, this line come from here. 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 This line is here. This line is here. This line is here. Okay, so that is how the combined convex hole is formed, right? As an illustration. If I just run another case, I use random, so you get all those random cases. That's another example, right? So for example, if you look at this line, yeah, that's how this line comes from. If you look at this this line, right? It's basically this line, and that one is this one. So all those edge, let me just call it periphery vectors, form this final convex hull. Okay. Once you know this, the code, the implementation of the code is basically straightforward, right? You basically, I mean, you know how to do convex hull. Basically, they have n group, right? So basically for n group, right? So you see in this group, you make the convex hull, right? That's a standard algorithm, right? We all know, right? So you know, let's say convex hull I, right? Then you make this, you know, remember these vectors. This, let me call it a periphery vectors, right? Then after you did this, then you sort this periphery vector by, you know, you have to have a comparison then, right? By the angle, right? Basically the octane, you know. Then you form the, then you travel through, you know, then you get the final one, right? Then you travel through this one, you know, let's say this is 0, 0, 0, and then you find the distance, right? X squared plus y squared. Then that you get then you basically you full loop through this vector, and then you get the max. Okay. So again, I will say this is a math problem. If you know how to do this, if you know the Minkowski addition, then you can easily solve this. If you don't, unfortunately, I don't think you could. Maybe you intuitively, if you make plot, you know, if you try a bunch of plot like I was doing here, you probably could make a guess and then figure that out. Otherwise, good luck. So this is, again, this is if you know the Minkowski addition, that is a relatively easy problem. It's just a convex hull, a standard convex hull, nothing fancy about it. Oh, there's a question here says, do I need to learn Python? No, you don't need to learn. And of course, you can use USACO allow you to use Python. I used it here because I use Python for plotting. I use the Matplotlib, and it actually have it actually has a convex hull algorithm in the SpecPy, SciencePy, in the SciencePy library. You don't have to learn Python. So you could use any other plotting if you want to do plot. You can use MATLAB, you can use S+, you can use many other things if you want to try. I just use Python because I'm used to it. So again, it's a math problem. So which means, right, you got to learn. A lot of USACO problems are combinations, right? Probabilities and some graphic things. So if you learn more on that, the better you will became. So homework today is obviously to implement this algorithm, implement this. I think that's straightforward, right? So it's a standard convex hull. Good luck today. Today's homework for problem number 2 and problem number 3 of January Platinum level USACO. Problem number 2, we talked a little bit earlier, is a BP problem. Problem number 3 is a convex hull mass problem.